Welcome to another 2011 FRC tutorial. In this video, we will be looking at the FRC Dashboard's analog inputs and digital inputs, and how to use them to make testing programs easier by being able to change values while the robot is running using the driver station's dashboard. When testing a new program on the robot, you generally need to run it from the computer and use controls on the front panel to be able to change values in real time. But this can also be done using the dashboard when the program is deployed to the robot. If we take a look at the robot dashboard, we can see that there is a tab called I/O. In this tab, we can see that there are digital inputs, digital outputs, and analog inputs. We'll ignore the digital outputs because we've already learned how to display information on the dashboard. There are 8 digital inputs that are binary values. There are 4 analog inputs that are numeric values ranging from 0 to 5. These inputs are already being used in the autonomous VI, but can also be used in the teleop VI. The getDigitalInput VI outputs an array of Boolean values, which can be wired into an index array. From this array, each Boolean value can be used individually, or multiple Boolean values can be used together as a number, as it is done in the autonomous independent VI. The getAnalogInput VI outputs 4 separate numeric values. Each of these values can be wired into a math function block if a different range of values is required. An example of using the analog inputs in the autonomous independent VI is to replace the steering gain with one of the inputs. We'll want a steering gain value that ranges from 0 to 1, so we'll be wiring the analog input into a divide function and creating a constant for the y input and setting it to 5. By replacing the steering gain constant with the first analog input, we can adjust the steering gain while we are testing autonomous mode, directly from the dashboard. Remember that the actual steering gain value is whatever the value is on the dashboard, divided by 5. The digital inputs are already being used in the autonomous independent VI to set the robot's direction. If, for example, we would like to set more directions, we can expand the build array function and wire in more of the digital inputs into it. Now we need to increase the size of this array and add values for each of the states we want to add. But first we'll make some space by holding down the control button and dragging the mouse until we have enough space. With an extra digital input, we will have a total of 8 combinations, so we can add a total of 4 more values. We can right-click on the array and click Edit Items to add different values. Click Insert to add an item, and then name it according to what the robot will be doing in this state. For example, we might want the robot to follow the right edge of the straight line, as opposed to the left edge. Therefore, we could call this state straight left. We can add up to 3 more states, but if we don't need them, we can just set each of the last 4 states to straight left. Now that we have our new state, we need to add it to our case structure. We'll do this by right-clicking on the selector label and clicking Add Case for every value. In the straight left case, we'll be going straight, so we'll use the straight power values and we'll copy the 2 seconds from the straight case and wire it in. We'll be following the right edge of the line, so we'll have to wire the steering gain value into a negate function. And wire the sensor outputs into a reverse 1D array function. If we want to test 2 completely different autonomous codes in the same program, we can create a case structure around all of the code inside of the while loop and wire a digital input into its case selector terminal. In the one case, there will be the default autonomous code, and in the other case, we can create a completely different autonomous code. These analog and digital inputs are very useful when you want to test your robot using the driver station, because each input can be changed while the robot is running from the driver station. Thank you for watching this tutorial, and stay tuned until next time.